In your time doing math, you might have came across binomial theorem, which is used in all kinds of algebraic manipulations. But do you know the proof of it? Me, myself, only know two proofs. First proof that I learned was this induction proof that Professor swiftly wrote on the blackboard. It took her 20 minutes to write everything out, and after I saw it, I understood it, but never really appreciated it. It took until university, where I saw the combinatorial proof, that I found the true appreciation for it. Now there's nothing inherently wrong with the induction proof, but it needs some prerequisites. First thing you need to know is the definition of n choose k, since we are using it. Next thing you need to know is the principle of mathematical induction, which in itself is a beautiful concept. After that, you need to know the Pascal's identity, which we will touch upon later in the video. And while doing the proof, you will need to be comfortable with working with the sum notation, change of variables and such. And even after you do know all of these, you don't really get the appreciation for the proof. You just know it works. And the worst part is, it's a lot of work. Here's a bit of footage of me doing the proof. And even after I am done, I would still need to prove the Pascal's identity, where I would need to know the formula for calculating n choose k. But on the other side, we have this beautiful combinatorial proof, which has prerequisites of its own. The first thing you need to know is the definition of n choose k. And after that, well, you don't need anything else actually. This is seriously all you need to do this proof. And after it, I promise you, you will understand it more deeply why the equation is true. So what is n choose k? Well, let's say we have a class of 20 students. We need to pick 3 students to make a group presentation about, let's say, why Trackmania Nations Forever is better than Trackmania 2020. In how many ways can we choose 3 students out of 20? Well, that is the definition of 20 choose 3. In general, if you have n students, and you need to choose k students to make a group project, in how many ways can you do that? That is n choose k. There is a formula how to calculate it, but for the purposes of this video, we don't really need it. And we're done. We are ready to tackle the proof now. To prove it, we'll take the left side and show that it's the same as the right side. We have a plus b to the power of n. This is the same as a plus b multiplied by itself n times. Now to multiply it out, we choose one term from each bracket, either a or b. Now for some number k, let's look at the term with b to the power of k. To get that, we chose k brackets out of n of them, where we picked b. Number way in which we can do that is exactly n choose k. Now if we picked b k times, then all the other times we picked a. So we get a to the power of n minus k. And that is it. All that is left to do is to sum for all the values of k. And we have the proof. First time I saw this, I was astonished. All the lines of induction replaced with a simple argumentation. This is not the only kind of combinatorial proof though. For example, let's take Pascal's identity. n plus 1 choose k equals n choose k plus n choose k minus 1. We can prove it doing some algebraic manipulation, but rather let's do a combinatorial proof. Let's take again n students, but this time add me into the mix. So we have n plus 1 students. The question is, in how many ways can we make a group of k people? Of course, it's n plus 1 choose k. But the other way of looking at it is that we have two cases. First case is that I am not in the group. Well, then we choose k people out of the remaining n students. So that's n choose k. Second case is that I am in that group. So we already picked one student, and we need to pick the other k-1 students out of the remaining n students. So we have n choose k-1. And if we add both cases, we get the result. We counted all the number of combinations in two different ways, so we conclude that they are the same. In mathematics, this is called double counting. Let's do one more for the road. We will prove this equation is true with double counting. So let's say we have n players and we want to make a football team of k players. We can do it in n choose k ways. And after we do it, we have to select one of the players to be the captain. We can do that in k ways. So we get k times n choose k. Other way we can make a team is to first pick a captain out of n players, and then pick the rest k-1 members of the team out of the remaining n-1 available players. We can do that in n-1 choose k-1 ways. So we get n times n-1 choose k-1. And that is the proof. That is it for this video. If you would like to know more about combinatorial proofs such as these ones, I would recommend you the book Proofs That Really Count by Arthur Benjamin and Jennifer Quinn. It contains cool combinatorics and most importantly, puns like the one in the title. You can count on that. Until next time, bye.